some numbers are really big. Take for example the mass of 237 grams of water. 237 grams of water contains about 79300000000000000000 molecules of H2O. I don't even think I can name that number. Some numbers are very small. For example, the approximate mass of a human cell is 0.0000000000001 kilograms. Working with very large or very small numbers is going to be important when working with astrology, physics, cell biology, and medicine. In chemistry class, you'll be using scientific notation a lot when it comes to unit conversions, molar mass, phase change, temperature change, and calculations involving solutions. Scientific notation makes it easier to understand or express big or small numbers, perform calculations involving big or small quantities, and decrease paper real estate. I think you really like this paper. It's nice and white, it has really nice blue lines, and there's a lot of space for you to write your numbers. Really? I'll take it. Thank you!
Imagine doing calculations like this.
With scientific notation, it's easier to express big numbers like this into something easier to read or say, like 7.93 times 10 to the 24th power.
It's also easier to express small numbers like this into something easy like 1.0 times 10 to the negative 12th power. Basically, scientific notation decreases the stress of having to work with ridiculously large or small numbers. So what is scientific notation?
Scientific notation looks like this: A times 10 to the power of B. A can be a number between 1 and 10 multiplied by 10 to the power of a number. To convert a regular number to scientific notation, we move the decimal point to the right of the first non-zero number. The exponent will be equal to the decimal places moved. So how do we convert a number into scientific notation? Let's begin with 1000 as an example. We want to convert 1000 into a number that looks like this. If there's no decimal point, we can assume that the decimal point is on the last zero like this. Next, move the decimal point to the right of the 1. Count as you go. 1, 2, 3. Notice how we moved the decimal point from right to left. Moving the decimal point from right to left will give us a positive exponent. Move the zeros and write your number in scientific notation. Be sure to ask your professor about significant figures. Now we have our number in scientific notation, where 1.0 is a number between 1 and 10. Multiply times 10 to the power of 3. When converting scientific notation into a regular number, look at the exponent. The exponent tells you everything. If the exponent is a positive number, move the decimal point from left to right. Think of moving the decimal point to the front of the line, which is a positive thing. Fill in the spaces with zeros and put your number together. Now we have our number in regular form. Did you notice the small number has a decimal point? We want to convert this number into something that looks like this, where a can be a number between 1 and 10, multiplied by 10 to the power of b. Locate the decimal point and move it to the right of the first non-zero number. Notice that we're moving the decimal point from left to right. Moving the decimal point from left to right will give us a negative exponent. Scientific notation allows us to simplify a number by getting rid of unnecessary zeros. Next, write your number in scientific notation, and you're done. Now we have a simplified number where 4.62 is a number between 1 and 10, multiplied by 10 to the power of -3. Let's convert 4.62 times 10 to the -3rd into regular notation. Remember that the exponent tells us everything. The exponent is -3. The exponent tells us to move the decimal point 3 places from right to left. Think of moving the decimal point from the front of the line to the back of the line, which is a negative thing. Next, add your zeros. Write your number in regular notation. And done. Thank you for watching our video on scientific notation. We hope you've enjoyed it.